Alright, in this video, we're going to take a look at another special case physics controller that we haven't really brought up to this point, but it is going to be important for you to know about, and that is the character controller.
Right, the character controller is special in the fact that it's not a true rigid body and it's not a true collider. This is a component that we can add to a game object to create a way for our characters, be them first person or third person, to interact with our world. Because it's not a true rigid body, though, it doesn't react to gravity. It also doesn't react to collisions, where if we get hit by something, that force imparts motion to us. The reason why is in games with our characters, say a first-person shooter, you want to be able to run really, really fast, stop on a dime, and that cannot be modeled with physics easily. We also want to be able to control the speed at which we jump and fall. So these don't. We need to separate our character from real-world physics and be able to apply the physics that we want to make the character act the way we want it to in the game.
Now, some things to know about the character controller is that while you do have control over a few specific properties, most of its functionality we don't really have access to right off the bat, do we?
Right. It's just like the wheel controller in the fact that the majority of its functionality is only available through scripting. Because this isn't a rigid body, it doesn't respond to gravity. So if you want it to fall, you have to code that in scripting. If you want the character to move, you again have to control that through scripting. There are a couple of things that we can set up via the Unity interface, things like the shape of the character controller and how steep it can climb, and we'll get into that in a second.
Well, let's just start off by taking a look at a character controller, and we don't even really have to create one. I already have a first-person controller loaded into my scene. Now, this came in along with the character controllers package that is included with Unity, and we've been using it every single time that we've been playing this game. We've already had this character controller ready to go. Now, earlier on, I was playing with the min-move distance, which we'll talk about here in just a moment. But if we select the first-person controller itself, we can see we have the character controller applied.
Right. It's a component, just like a regular collider or rigid body or any other of the components that we've been talking about. But it is a special case component.
Now, let's take a look at its properties. First off, we have some properties that essentially are just a regular plain Jane capsule collider. We have height, we have radius, which I can adjust here, and we have our center, which we can use in case we need to offset it. And offsetting your controller vertically might be very useful depending on how your character is set up.
Right, and if you watch the capsule collider video when we're going over that, notice we can't change the orientation of the capsule. It is only oriented in the Y direction.
Right,
this is one of the things that makes it different than a capsule collider.
Right, and also, I mean, it kind of lends itself well to a bipedal upstanding character. Maybe not necessarily to a elongated quadruped or something like that. Just keep that sort of thing in mind. It's not to say you couldn't use it, but it probably wouldn't work in an extremely convincing way upon close scrutiny. So let's kind of take a look at some of the rest of the properties. So we've seen the shape controls. Next we have slope limit. This controls the maximum slope that you can still climb. Now by default this is set to 45 degrees. So if I jump into my game and I try to climb this hill, I can go right up this hill with no problems. But as I get into some of the really steep climbs, at some point we'll reach something that we simply can't climb, like right here. We're actually sliding back down. We cannot go up that, and that is because our slope limit is set to 45 degrees, and that's a greater slope than 45. Now 45 is actually pretty steep, but if we wanted to, we could pull that down to something really low, like 10 degrees. And now, as we try to move forward, as soon as we hit a value greater than 10 degrees, we can no longer climb. We just get cut off. So you can tweak that to control where your character can and cannot go. If you're running into problems with your games where your character can just seemingly climb into areas you don't want them to, you can tweak this value and finesse it so that you can have a certain slope of your terrain that they simply can't go up, and thereby solve that problem.
Now the next one is step offset. Now step offset is going to control how high up in the air you can go without bumping into something. If we set it to something like 0.4, something low, and run over to the benches, you'll see that instead of stepping up onto the benches, we get stopped by them. It's almost like there's a low standing wall that we just can't go over the top of.
Kind of bruising your knees on it.
Right. But if we go and we set it to something like 1, we can go back to the same bench and go right over the top of it.
And boom, we just pop right over the top. So you can use this to control, like if you've already got your level designed and someone has built stairs that are a little bit too tall and you're getting hung up on them, you can increase this value and you'll start jumping up those stairs. You'll notice, though, that you got to be a little careful with it because there is a visible pop as you jump up there. Because this is not like a physics simulation where you're smoothly interpolating up or jumping up or even smoothly popping back down. I mean, you're really, in this case, you're just popping up and popping back down over what feels like a single frame.
Right, because this is not being controlled by physics. What's happening is internally it's determining how the distance of something it hits below it via a raycast. And then it just jumps up your height to match.
That's right. Now, down from here, we have our skin width. Now, how does this work?
Well, skin width works by determining how far into our capsule will something be allowed to penetrate before it says we've collided with something and tries to correct for it.
And if you're having a hard time gauging collisions off of a moving character, you can increase or decrease this value for finessing purposes.
Right. This comes in handy if for some reason your character is getting hung up on some small pieces of geometry. You can increase this number to help correct that.
Mm-hmm. Now, finally, we have min move distance. And this one's kind of cool. What does this do?
Well, min move distance is a minimum amount that we have to, or the minimum amount in which we have to move greater than for our code to detect the motion.
Okay.
So if we're using the functionality, again, this is only controlled via script, if we tell our character controller to move by a certain distance, and that distance is not greater than the min move distance, our character will not move.
Gotcha. So just as an example, if I was to take my min move and set it up to 1, this means over, a single frame we'd have to move a whole unit. And now if I hit forward, I'm actually not getting anywhere.
Right. And just because of the way the key controllers work, they work on a 0 to 1, so you're never going to be able to move that far in a single distance. But if you set it to something like 0.05, you might be able to get it.
Right, and this would be a lot more useful if you had like analog control to make your character move, so that you could set up a system where, if the tiniest amount of pressure was being applied to an analog joystick and you didn't want the character to drift, and that kind of pressure might not even come from the player. It could come from a really old joystick, which is out of calibration. So it's almost, in a way, kind of like setting up a separate dead zone, where you've got to force the character to move a certain distance before any motion is registered whatsoever.
Right.
It'll prevent drifting in analog scenarios.
Right. And there's something else I'd like to show. If you go ahead and play and then quickly run in front of the car as it's rolling down the hill,
Sure.
you'll notice that it stops the car.
Yep.
But the car doesn't push you.
Bump. I can back up, and it keeps coming at me, and bump. Yep, we can stop it, but it's not affecting us.
Right. We're not a rigid body, so the physics simulation is not affecting the character controller. But we do affect the physics system in the fact that it's acting like a collider for all the other rigid bodies in the scene.
That's right. So that's just a quick rundown of the character controller. If you're building character systems, you'll probably be using these. They are found underneath the physics components, though they don't really fit in extremely well with the physics systems that we've discussed up to this point. But I did want to make sure that you did get a chance to see them. That, however, will wrap things up for this video. Thank you very much for watching.